Okay, this is just a quick video covering some of the topics that I wasn't here for last week. I hear Dr. Devereaux was a little bit under the weather, so this is just a bit of a bonus session, and I'll upload these lecture slides onto Learn very soon. So here we're just going to be talking about Pythagoras' theorem and how we use that to calculate resultant forces. Now, this isn't going to be a full 90-minute session, so what I will do is I will point out specific areas during this short talk where you will perhaps need to go away and do some wider reading, but I will certainly point you in the right direction. So the first thing we need to do is just familiarise ourselves with some basic functionalities on our calculator. So you will need a calculator, or it's useful if you have one, because we're going to work through some examples here. Also, I will point out during this video moments where you can pause it if you so wish and have a go at some of the practice questions that are going to come up. So it's entirely up to you then. So we're just going to start with some basic stuff before we move on to some of the trickier topics in the following videos. So we're just going to start with squaring a number and rooting a number. So when we square a number, we are essentially multiplying it by itself. So 2 times 2 is going to be 4. 4 times 4 is going to be 16, and so on. But what we can do is use this button here, this function here, which is the square button, which on my Windows calculator, apologies for the creaky chair, I have a very, very creaky chair in my study, apologies for that in the background. Anyway, the square button on my calculator here is this button that you see highlighted in yellow, this X with the superscript 2 on the right hand side. So we can press 2 and square button and we will get 4, 2 times 2. We can click 4 and the square button and we will get 16. Okay? Now, square rooting a number is the exact opposite of squaring it. When you enter a number and square root it, you will be given the number which, when multiplied by itself, gives you the original number you entered in the calculator. And the square root button on my calculator is here. It's this weird sort of elongated tick symbol, which is known as the radical symbol here. So if we put in 16 and click the square root button, we get 4, because 4 times 4 is 16. If we type in, let's say, 81 and square root it, we get 9, because 9 times 9 is 81. Okay, so if you're unfamiliar with squaring a number and square rooting a number, I would advise you to stop here and just practice that a bit more before you continue. Okay, well, let's move on then. So this is Pythagoras' theorem, and it is a calculation that is used to gain information about right-angled triangles. And this is a right-angled triangle that you can see on the slide in front of you. The right angle being the 90-degree angle in the bottom left-hand corner of this triangle. Now, Pythagoras was an ancient Greek mathematician, and he did some rather funky stuff with geometry and triangles and one thing and another. And if you're interested in that, I would certainly recommend going and reading it. But for the purpose of what we're doing for this talk, we're just going to focus on covering the basics. So for our theorem to work, we need to label the sides of our triangle. And all that you need to remember is that the side that is opposite to the right angle, i.e. the longest side on this triangle, is always labelled as C. The other two sides can be labelled A and B. You could swap A and B around here and it wouldn't make any difference. and that's simply just a way of labelling the triangles. There's nothing special about saying A, B and C. You could have called the sides 1, 2 and 3, but if we're going to be measuring those sides and you label the sides 1, 2 and 3 and then the measurements are different from 1, 2 and 3, it just causes confusion. So they're labelled A, B and C. And Pythagoras' theorem simply states that the square of this longest side, so when whatever the length that longest side is, the C side, if you square it, it will be equal to the sum of the square of the other two sides, if that makes sense. To try and explain this, you can actually see that there are three squares set up around this right angled triangle, and the square that is the C square basically has the same area as the B and the A square put together. So it is equal to the sum of those two squares. So let's do an example. It's usually the best way to get the hang of things like this. So we're going to look at a jumping scenario, hint hint, and imagine in this situation you see in front of you where we're doing a track and field event, presumably some sort of long jump. Imagine underneath this person's foot there is a force plate, and we measure the vertical and horizontal force that this person produces at the moment of takeoff. Okay, and there they are, vertical and horizontal. Now, if we were to use our second law of motion, Newton's law of motion, and borrow the equation from that, F equals ma. We have here the forces, we have the vertical and the horizontal force. We could weigh our athlete, the one who's doing the jumping, and from that we could measure the vertical and the horizontal acceleration. And that's super duper important because we want to see the forces that are produced, but likewise we want to see the product of those forces. How fast is this person accelerating? Oh, sorry, squeaky chair. So it's very useful to do, but whilst we've got the vertical and the horizontal forces and acceleration, it would be even better if we could figure out the resultant acceleration and force. Because this person is jumping up and forwards, well, that's what we kind of want to know. Yes, they're jumping up, yes, they're jumping forwards, but what is the product of those two directions? Well, it's this, isn't it? It's going to be somewhere in between the two, somewhere between vertical and horizontal. So here, this red line represents the resultant acceleration, and here we see the resultant force. Now, how do we use Pythagoras' theorem for this, I hear you cry? Well, if we take away the background and rearrange these arrows for the forces, you can see that they conveniently make a right-angled triangle. And so if we know the size of the horizontal and the vertical force, we can use Pythagoras' theorem to calculate the resultant force. So let's do that. So what I've done here is I've just taken away the arrows and just created a triangle here, a right-angled triangle, just to show you that this isn't nonsense and using triangles, this does work. So let's bring up our equation again. A squared b squared equals c squared. Now just have a go at labelling the sides. Which side would you label? A, B and C. So pause the video and just take a second to do that. Okay, so as we said, the side that is labelled C is opposite to the right angle. It's the longest side on the triangle, so that would be here. And it really doesn't matter what way you labelled A and B. That could either be the vertical or the horizontal side of this triangle, which represents obviously the vertical and horizontal forces. But in this case I've gone A, horizontal, B, vertical. Okay. So let's imagine, go back to our example and say that we measured the vertical and the horizontal forces produced by our jumper in the previous example. And we found out that the horizontal force, which is represented by A on our triangle, was 500 newtons, and the vertical force was represented by B on our right angled triangle, was 300 newtons. Now that's useful, but you can see that Pythagoras' theorem requires us to square those numbers. So that is, you need to multiply them by themselves. So just take a moment to do that now. Okay, you should have got, for 500 times 500, 250,000, and for 300 multiplied by 300, or 300 squared, you should have 90,000. So Pythagoras' theorem tells us that a squared plus b squared will give us c squared. So all we need to do now is add a squared and b squared together. Away you go. And you should, I've just cropped that out of the recording, apologies. You should have got 340,000, okay? So we figured that out, what c squared is, but we can be fairly confident in thinking that our long jumper didn't produce 340,000 newtons of force. So that's clearly not the answer. So we need to find out what c is. We currently know what c squared is, but we want to know what c is. So in order to do this, we need to square root 340,000 to get the number which, when multiplied by itself, will give us 340,000. So just type in 340,000 and hit the square root button. Okay, and you should, if you can just about make that out, have got 583 newtons. So our long jumper, going back to our previous example, produced 300 newtons up. Well, I should say, actually, no, if we're going to use the law of reaction, they push down with 300 newtons of force and push backwards with 500 newtons. The floor then, or the ground I should say, pushed up with an equal and opposite 300 and 500 newtons, and that created a resultant force that was 583 newtons. Now I hope that makes sense. What I've added here is the mass of our long jumper as well, which is 75 kilograms. Now, what we can do is we're going to work out the acceleration values using Pythagoras' theorem. But what we can do is we can also work out the acceleration of the athlete using F equals ma. Now, we, in this instance, know the force value for the vertical, the horizontal, and the resultant. We know this person's mass, but we need to know the acceleration, so we need to rearrange the F equals ma equation to make A the subject. And that will look like A equals F divided by m. So to get the acceleration, you need to divide the force by the mass. Now, you can do this for all three force and acceleration directions, the horizontal, the vertical, and the resultant. But just for the sake of this example, just work out the vertical and the horizontal acceleration. Leave the resultant for now. I'll give you a few minutes. Well, take as long as you need to do it. I will just pause here. Okay, so here's our triangle again. And this time, instead of looking at the forces, we're going to use the exact same triangle to look at the acceleration. And we're, instead of calculating the resultant acceleration by rearranging F equals ma, which you may have done already, but we're going to just use it to practice a bit more Pythagoras' theorem. So you should have got, for the horizontal acceleration, you should have divided 500 by 75, and you should have got 6.7. And to get the vertical acceleration, you would be dividing 300 by 75, and you would have got 4 meters per second squared. So that is our vertical and horizontal acceleration. So now we are going to try and work out the resultant acceleration using Pythagoras' theorem. So you're going to work through the entire example in one go this time. So you need to square these two numbers, add them together to get c squared, and then square root that number to get the resultant acceleration. Away you go. So you should have got for a squared 44.9 and for b squared 16 meters per second squared. Okay. Now we add these together and we get 60.9 meters per second squared, if you can just about make that out. That's 60.9. Again, apologies for the rubbish video editing. Now if you square root that number, you would have got 7.8 meters per second squared. Okay. So that's the end of this video. If you feel confident with this, then by all means carry on to the trigonometry video. If not, then I would really recommend having a look at some Pythagorus's theorem revision material. I'm not going to put up any online. I know it probably sounds a bit lazy, but there is tons of it online. It's all over the place, so you can easily find some material for this. But if you're confident with this, then by all means move on to the trigonometry video.